Our question is to implement power function, which calculates x raised to the power n. In this question, we have asked to implement a function which calculates power of any number, whether it is negative or positive, okay? So before moving to the solution, let's consider the scenarios we need to address. For the base, let's say if n equals to 0, then return 1 because any number raised to the power of 0 is 1. Let's take the example of 2 to the power 10. So start with the brute force approach. Let's say n starts at 1, and then we multiply it by 2, a total of 10 times. And finally, return the result, which will be 512. While the brute force approach works, it's not efficient for large values of n as it involves n multiplications. So, instead of repeatedly multiplying x by itself n times, we can optimize the solution by dividing the problem into smaller subproblems. For example, if n is even, we can calculate x power n as square of x raised power n divided by 2, which requires only n by 2 multiplications. For example, for 2 raised to the power 8, rather than multiplying 2 by itself 8 times, we only need to multiply 2 square by itself 4 times. This significantly reduces the number of multiplications needed, making the solution more efficient. Similar to even exponents, if n is odd, we can still apply a recursive approach, but we need to adjust the exponent. For instance, for calculating 2 raised to power 5, we can calculate it as 2 multiply 2 square raised to power, which involves one additional multiplication compared to even exponents. So, handling odd exponents is analogous to handling even exponents, but we multiply x once before applying the recursive step. By handling both even and odd exponents recursively, we optimize the solution and reduce the number of multiplications required compared to the brute force approach. Based on the observations, we can formulate a recursive approach. Let's see all the steps for solving question. If n equals sign 0, return 1. If n is negative, return 1 divided by mypow function, and the parameters will be x and minus n. If n is odd, return x multiply mypow function, and the parameters will be x and n minus 1. If en is even, return mypow function, and the parameters will be x squared and en divide by 2. Let's implement it. We'll start by handling the base cases. If n is 0, we return 1. Next, if n is negative, we return 1 divided by mypow function with parameters x and minus n. If n is odd, we return x multiplied by mypow function with parameters x and n minus 1, which recursively calling the function with n1 to handle the odd exponent. Finally, if n is even, we return mypow function with parameters x multiply x and n divided by 2, recursively calling the function with the square of x and n by 2 to handle the even exponent more efficiently. So, by implementing this recursive approach, we can efficiently compute x raised to power n for both positive and negative exponents, significantly improving the efficiency compared to the brute force approach. So, that's all about this problem. Thank you for watching.